If a silicon diffusion is doped with phosphorus donors at a concentration of the following graphs, what is the concentration of holes in this piece of silicon per cubic centimeters? Now we can assume Ni. We also have a micro N and a micro P. We can use the notes that are in that description below the like button. And in there, on about page 28, creation of electron hole pairs in silicon. It's a really nice section. We have some notes that we're going to use. I'm also going to write them out here. So looking at this question, there's a few things that we can note down. Well, actually, there's like a couple things. Yeah, a few things. So this first part is very important right here. If a silicon diffusion is doped with phosphorus, this is a donor at a concentration of 0.1, 10 raised to the power of 17. What is this? Well, this is going to be our N subscript N and then N subscript D. So N subscript N is approximately the same thing as N subscript D. And this is going to help us solve for this. So this is really N subscript N, but we're saying it's about N subscript D. Now, what we want to find is the hole concentration of holes, right? So to solve for this, we can go into these notes and we're going to see that we have a Pn is equal to, and this is approximately, so this is also not equal to, this is also approximately. It's going to be N subscript I squared divided by capital N D. So what is this equal to? Well, this is going to be equal to our Ni, which we actually conveniently have right here in our problem. It should be given in the problem. It's going to be 1.45 times 10 raised to the power of 10. This is going to be squared. And then we have our cubic centimeters, but this is divided by, so if we want to bring it on top, we got to flip the exponent signage. So this is going to be cubic meters negative cubed, but it's squared, so instead of negative cube, it's going to be negative sixth. Now, let's put this over our ND. So we'll draw our line right here. What is our ND? Well, the ND is given to us up here in red. So our ND is going to be 0.1 times 10 raised to the power of 17. And in the same process, we have cubic centimeters. And so if we plug this into a calculator, we're going to get the following as our answer. We're going to get that our Pn is equal to approximately 21,025 negative cubic centimeters. So this is going to be our answer. And this is exactly what we want, or what we were solving here. This is per cubic centimeters, so this is really like a divided plus 3. And that's going to be the answer for this problem. That's how we would go about doing it, with those notes in the description below that like button. These aren't exactly my notes, but professor's notes copied into Google Docs.